A polynomial is an expression that can be written as a sum of terms consisting of constants, variables with non-negative integral exponents, or products of a constant and one or more variables. So a couple things here. A constant, that's a number. A variable, that's a letter representing a set of numbers. Non-negative, so your exponents in polynomials cannot be negative to be considered a polynomial. And they have to be an integer, so you can't have a fraction as an exponent either. So it has to be integers that are positive integers or whole numbers. Or a product, so you can have a number times a variable. Sum of terms, so you can take one term and you can add and subtract it. A monomial is a polynomial with 1, binomial with 2, trinomial with 3 terms. The degree of the term is the sum of the exponents of its variables, and the degree of a polynomial is the highest degree of any one term. So we're going to go through some of these examples. On your handout, it looks like this. So a polynomial can be written as a sum of terms. The sum of the exponents, that is the degree of any one term. A monomial is a polynomial that has one term. Binomial has 2 terms. Trinomial has 3 terms. Standard form. This is an expression in standard form when they are ordered in greatest to least degree. The degree of the polynomial is the highest degree of any one term of the polynomial. And then the coefficient of the first term is called the leading coefficient. So I'm going to give you a few minutes to fill that in. So the first thing we're going to do is we're going to decide, are these polynomials? Actually, they want to know if they're just monomials, one term. If they are, we're going to say what the degree is. If they're not, we're going to say why. So we're going to take this first one, 4x to the 1/3. Is this a monomial? So we're going to say no, it's not. Why is this not? What's wrong with this one? Right, the exponent is a fraction. We cannot have a fraction as an exponent. It must be an integer or a whole number. All right, so that one is not a monomial. Let's look at the next one. We're going to take 58. Is 58 a monomial? Yes, it is. All right. The degree. So the degree is the highest exponent on the variable. If you do not see a variable, it is to the degree of 0. So any constant has a degree of 0. And by the way, you can think of this chart like this, right? There's kind of a dividing line there. So just think of it as these are two separate things here. All right, let's look at the next one. 2 plus m, is this a monomial? 2 plus m, is this a monomial? No, a monomial only has how many terms?
1.
Right, so this is 2 terms. This is a polynomial. So this is a binomial, not a monomial. This is a binomial. All right. What about 6x? Is this a monomial?
Yes.
Yes. What's the degree? The highest degree, yes, is the exponent has a degree of 1. Degree of 1. Let's look at the next one. Negative 3.4 y to the 4th.
No.
Why not?
Because it's a decimal.
Yeah, so we can have a negative coefficient. We can have a decimal coefficient. We cannot have a negative or a decimal exponent.
So the degree is 4.
So the degree is 4. All right. Let's look at the next one. 3 halves xy squared. Is this a monomial? Yes, it is, actually. We can have multiple variables as long as they're multiplying. It's a monomial. We can have a coefficient. That's fine. So now this one's where it's tricky. When you have a monomial, the degree is the sum of all of them. All right? So this is actually, since it's just one thing, if we go back, when I look at this one, I need to add up all the exponents of my variables to figure out what my degree is. So what's the degree on this one?
3.
The degree here is 3. All right, let's look at this one. N to the negative 2, is that a monomial? No, what's the problem here?
Negative exponent.
Yeah, my exponent must be positive. And let's look at this last one. 7 to the x. Is x an integer? No, x is a variable. So we can't have a variable in the exponent position for a polynomial, for it to be considered a polynomial. So my exponent must really be a whole number. Not a variable. So they give us an example of a monomial. They give us examples of binomial and then trinomials and other polynomials. Once you get past 3, it's just a 4-term polynomial or a 5-term polynomial. What I want to point out is that they ordered them. You'll notice that they have the x squared, then the x, then the constant without the variable at all. When they had multiple variables, they actually did it in a different form, and we're going to do it a different way than what they did. So we'll look at this one right here. So for this one, you'll see they started with the x cubed, and then they went down to when they have x's, and the y's actually went in a different order. So we're going to talk about standard form because some of these are in standard form and some of these are not in standard form. When you write a polynomial in standard form, you have to find the degree of each term, and then you're going to do your standard form from highest to lowest degree of your terms. And you'll notice it says if 2 terms have the same degree, use alphabetical order. So if you have an x squared and a y squared, you're going to put the x squared first, even if they have the same degree. So we're going to find the degrees and then we're going to put them in order from highest to lowest. This says write them in standard form, identify the leading coefficient. So we're going to look at these and we're going to say, okay, I am going to look at all of these terms and I'm going to say, what's my highest exponent? X cubed is my highest exponent, so that one goes first, 7x cubed. Then I'm going to go down from there. So what's my next one going to be? Yeah, so it's the one with the x squared. You'll notice it has a minus in front of it. That goes with it. So we're going to say minus 5x squared. And then my next one is going to be that positive 3x. And then I'm going to end with this 7. Is that a positive 7 or a negative 7? Positive, so I'm going to say plus 7. All right? That is standard form. The leading coefficient when you have it in standard form is the first number in the polynomial. In this case, a 7. So my leading coefficient is 7 here. The coefficient of the first term when you have it in standard form. Let's look at the next one. So we have 2x plus 3y minus xy. 2x plus 3y minus xy. All right. For this one, I am going to find the one with the highest degree. Well, what's the degree of this term, 2x? What's my exponent? 1. What's the degree of 3y? What's the degree of xy? So the xy is going to go first. And because there's a minus in front of it, we're going to say a negative xy goes first, all right? 2x and 3y have the same degree. So for those, we're going to go in alphabetical order. In alphabetical order, 2x would go first, 3y would go second. And that would be standard form. My leading coefficient would be the first number when it's in standard form. What is that first number? -1. That is standard form for that. Let's look at the last one. When I look at this last one, I have a degree of 2, a degree of 3, 1, and 1. So I'm going to start with my degree of 3, -5y cubed. Then I'm going to go to my degree of 2, +1/2 x squared. I have 2 of them with a degree of 1, alphabetical order, -x plus 6y. And my leading coefficient here is my first number now that is in standard form, -5. All right, so try those 3, 2, 4, and 6 on your page there. Put those in standard form and then list your leading coefficient. So we also classify polynomials. When you classify polynomials, you want to make sure that you have it in standard form, and you want to make sure that you have combined any like terms before you decide how many terms are in it. So if I were to classify this, I would first put it in standard form to make sure that I've accounted for everything. So I'm going to say -5x to the 4th plus 7x cubed plus 6x. And so if I were to classify this by degree and number of terms, I would say that this is a 4th degree trinomial because it has 3 terms, okay? 3 terms. Before I can do that, though, look at number 3. I have to make sure that I've combined everything, because if you just look at number 3, you may say that's 4 terms. But it's not, because I have some that are alike. I have a -xy, a -8xy, and a 1xy. So I want to combine these two first. -8 and +xy is -7xy. I also have a 9y and a -2y. I want to combine those. 9 minus 2 is 7y. And now you can see that I have, this degree is 2, so this is a 2nd degree binomial. Okay? Let's look at the last one. For this last one, I'm going to start with my highest degree, that's -4y cubed. Then my next degree is going to be squared. Well, these are the same thing. So I have a +1/2 and a -1. That gives me a -1/2 x squared. The 4y cannot combine with anything. And the 11 cannot combine with anything. So I do have a 3rd degree. But once it's 4 terms, you can just say it's a 4-term polynomial or a polynomial. Because there is no special name for 4 terms. Monomial, binomial. So anytime you see evaluate, it really means solve, okay? And so evaluate, they want you to solve for an answer here. They've given you a polynomial, 2x squared minus 5x plus 6, and they want you to evaluate it when x equals 3. Evaluate just means plug it in and solve. So anywhere there's an x, we're going to plug in a 3. We're going to say 2 times, and instead of x squared, we're going to say 3 squared, minus 5 times 3 plus 6. At this point, you're doing order of operations. So we're going to do exponents first. That 3 squared is a 9. So we have 2 times 9 minus 5 times 3 plus 6. Order of operation tells us to do multiplication now. So we don't have any division. So we have 2 times 9, that is 18, minus 5 times 3, that is 15 plus 6. And now we can just add from left to right. So 18 minus 15 plus 6 equals 9. That is what happens when we evaluate. Let's look at the next one. This one has x's and y's. That's fine. We're just going to plug in whatever it tells us to plug in. So we have 5x cubed y. 5x, they've told us, is negative 2 cubed times y, which is 1, minus 2 times negative 2. Oh, that's plus 2 times negative 2, minus 3 times 1, plus 5. And again, you have all numbers. We're just doing order of operations. So we're going to take this cube first. We have 5 times negative 8 times 1, plus 2 times negative 2, plus 3 times 1, plus 5. Multiplication from left to right. So we have 5 times negative 8 times 1, that's negative 40. You can say plus a negative, or you can say minus here. 2 times negative 2 is negative 4. 3 times 1 is 3, plus 5, and then we just go from left to right. Negative 40 plus minus 4 is negative 44, plus 3, plus 5. That's a minus. Is that a minus 3? Oh, yep. I jumped it. That should be minus 3. Minus 3 plus 5. We get negative 42. So we're just doing order of operations at this point. Plug it in and do order of operations. So remember, we have our any parentheses that we have are grouping. Exponents will be next. Multiplication and division from left to right. And remember, you don't do all of one or the other. You do it from left to right, and addition, subtraction from left to right. All right, so if you don't remember of order operations, there you go. Pay attention to your negatives. You'll notice that if you plug in a negative, I grouped it because you need to know if this is going to be positive or negative when you take it to a power. So there are two methods of solving when you have adding and subtracting. In this case, we're taking an entire polynomial and we are adding it to another polynomial. The first method is the horizontal method. You just pretty much pull out your like terms. When you're adding polynomials, all you're doing is you're adding like terms. And so if you look at this first one, example that they've given us here, we have 3x squared plus 6x minus 4, and they want us to add it to x squared minus x plus 3. So we're going to say, well, I have 3x squared plus x squared. Then I have 6x plus a negative x. Then I have negative 4 plus 3. And you'll see that I just pulled out my like terms and grouped them. And then you're going to simplify those. So when I add my 3x squared and my 1x squared, I get 4x squared. When I add my 6x and my negative 1x, I get 5x. And when I add negative 4 and 3, I get negative 1. My answer should be in standard form, so I should have combined all of my like terms, and it should be highest to lowest degree. And that is my answer. Okay? The second method that you can do is called the the vertical method. So that's actually on the next page if you flip in your little handouts. When I give these to you, they will be out side by side. So if you want to do the vertical method, you're welcome to do it. You'll have to rewrite it. And so what they've done is, one, they have made sure that they are both in standard form. And then they have just lined them up. Okay? So they've put the first one on top, the second one on bottom. If you're missing a term, you need to make sure you have lined it up with the like term. So they've just written this guy, they've added it to that guy, and they've made sure they lined those up. And then they just added down -4 plus 1. And you'll see they grouped them again, but you don't really have to group them again if you've lined them up this way. -4 plus 1 is -3. -4 plus 6x is +2. 2 plus -4 is -2. And you can really solve these either way. I'm not going to make you solve them one way or the other. Okay, so you can solve them by the horizontal or the vertical method. But I will say, when I give you these problems on a worksheet or on a quiz, they're going to be out this way, horizontal, and you'll have to shift them to add them vertically if you choose to do it that way. We have 3x squared plus 2x minus 5 plus 8x squared minus 7x minus 10. And so if I do my horizontal method, I would say 3x squared plus 8x squared. And then I have a positive 2x plus a negative 7x. And then I have a -5 plus a -10. All right. And so when I combine those, 3 and 8 give me 11x squared. Positive 2 and -7x give me -5x. And -5 and -10 give me -15. If these had been positive, you would have wanted to put a plus in between them, because it is the sum of terms. So you don't want just random terms with nothing in between them. It needs to have a plus or minus in between them. So if these terms had been positive, I would have put a plus there, because your polynomial needs to be all your terms with adding and subtracting in between them. And so this would be my answer here, 11x squared minus 5x minus 15. Difference just means subtraction. And so I will say the biggest issue that I see with subtraction is paying attention to your positives and negatives. You have to remember that you are subtracting the terms. And you can do the same thing with these methods. You can either do them out, and you can say, well, I have 5x squared minus 6x squared. I have 0x. It's possible that you do not have a term, so you may want to put 0. Minus a -3x. Here's where we have my biggest problem. Don't forget you're subtracting between the two terms, so here you are subtracting a negative. And then I have -4 minus a 2, so -4 minus 2. And then I'm just combining them. 5 minus 6 is -1. 0 minus a -3 is +3. -4 minus 2 is -6. We can do the same thing, the vertical method. Pay attention. You'll notice this first guy didn't have a constant. So they did 8x squared minus 2x, but then they put a 0 here so they could remember that they were subtracting. They lined up the -2x plus the 4x minus 10, and then they are subtracting down. 8 minus a -2, that's 10. -2 minus 4, that's -6. And 0 minus a -10, that is 10. This is where I see the biggest issue with positives and negatives is right here, okay? I will say, you can do adding the opposite, and you can change this to a plus and change every single sign here, but sometimes people mess that up more. I find you do better with difference, with subtraction, doing this right here, than lining it up, because lining it up, people get confused on this. When they get over here, they forget they're subtracting. Okay? And so I would recommend that you group your like terms and always remember whether you're adding or subtracting in between the two. All right? For this one, my like terms, I have a 3x squared. I am subtracting a 4x squared. I have a 2x, and I am subtracting a negative 5x. And then I have a negative 5, and I am subtracting a 2. And I'm going to combine those. 3x squared minus 4x squared is negative 1x squared. 2 minus a negative 5. What is 2 minus a negative 5? That is 7x. And then I have negative 5 minus 2 gives me a negative 7. And that is my answer for that one.